Hello, my name is Cristina Cruz, and this is my Lewis dot structures video for Chemistry Honors Period 1. So, to figure out the Lewis dot structure for any compound, we need to follow 3 general steps. First, find the total number of valence electrons among the atoms of the compound. Second, figure out the number of bonds in the compound. And third, use this information to draw out the structure. Simple. Let's go through a couple of examples to help you understand this better. For our first example, we'll use the compound hydrogen cyanide. That's HCN. 1 hydrogen atom, 1 carbon atom, and 1 nitrogen atom. Step 1 is to find the total number of valence electrons among the atoms of the compound. To visualize this, let's illustrate the separate Lewis dot diagrams for each of these atoms. Hydrogen has 1 valence electron. Carbon has 4 valence electrons. And nitrogen has 5 valence electrons. This adds up to a total of 10 valence electrons. Now, Step 2 says we need to figure out the number of bonds in the compound. To do this, we take the total number of valence electrons that we figured out in Step 1 and divide this number by 2. The number we get from doing this will end up being the total number of pairs in the compound. So, for our example here, 10 divided by 2 will give us 5 pairs. Next, we look at the Lewis dot diagrams we drew earlier to see if there are any unshared pairs. If so, we subtract the number of unshared pairs from this number here. If we take a look, we'll see that here is 1 unshared pair in nitrogen. 5 minus 1 gives us 4. The final number is the total number of bonds in this compound. There are 4 bonds. Step 3. Draw the structure. The atom with the most openings will go in the center of our structure. In this particular compound, carbon has 4 openings, as opposed to nitrogen, which only has 3 openings, and hydrogen, which follows the rule of duet, and therefore only has 1 opening. We can now put hydrogen and nitrogen on either side of carbon. As I mentioned earlier, hydrogen follows the rule of duet, so we can satisfy this by bonding it with carbon. Now, carbon is left with 3 openings, and nitrogen also has 3 openings. We can satisfy this by creating a triple bond between carbon and nitrogen. These 2 atoms share 6 electrons between them, and because of this, carbon now follows the rule of octet, with these 6 electrons and the 2 electrons from its bond with hydrogen for a total of 8. Nitrogen also follows the rule of octet, with the 6 electrons shared between it and carbon, and the 2 electrons here from its unshared pair. All of these atoms are satisfied, and if we take a look back here, we see that we have 4 bonds and 4 bonds. We now have a complete Lewis dot structure for hydrogen cyanide. Our second example is a sulfite ion, SO3 -2. That's 1 sulfur atom, 3 oxygen atoms with a -2 charge. First, find the total number of valence electrons among the atoms of the compound. If we draw the Lewis dot diagrams for these 3 atoms, we'll see that sulfur has 6 valence electrons, as well as oxygen. So 6 from the sulfur plus 6 from the oxygen times 3 because we have 3 oxygen molecules for a total number of 24 valence electrons. Second, figure out the number of bonds in the compound. 24 divided by 2 gives us 12 pairs. If we look back at our diagram here, we can see that there are 2 unshared pairs in 1 sulfur molecule and 2 unshared pairs in an oxygen molecule. We have 3 oxygen molecules, giving us 6 unshared pairs. This adds up to a grand total of 8 unshared pairs. 12 minus 8 gives us 4 bonds. Third, use this information to draw out the structure. We'll put sulfur in the middle and put the oxygen surrounding it. We'll use these 3 bonds to bond the 3 oxygen molecules to sulfur. These oxygen molecules are now satisfied as they all follow the rule of octet. However, sulfur still needs 2 more electrons to satisfy this rule. Sulfur will then borrow 2 atmospheric electrons, which we'll place here and it now follows the rule of octet. Remember, additional electrons result in a negative charge, so the 2 borrowed electrons from the atmosphere result in a -2 charge. And here we have our completed Lewis dot diagram for sulfide. So in conclusion, here's an overview of the steps we covered to figure out the Lewis dot structure for any compound. Alright, that's all I have for you. I hope this video helped you understand this concept. Thanks for watching.